I'm Emma Dickson. My pronouns are they, them. I work at IBM in a small 4-person squad, and this year we did kind of an Octoverse-inspired internal, which is why I'm here to talk to you today. So the talk is called Insights into GitHub Enterprise, How IBM Analyzes the Impact of GitHub Adoption. So I want to give a little context about where my small 4-person squad sits within IBM, because I think it's helpful to understand why we undertook this project in the first place, why it was interesting to us. So we sit under Toolbox, and Toolbox is the larger group within IBM that works to bring the best third-party tools in the industry, things like Slack, GitHub, Safari Books, to IBMers in order to support their work. And we manage instances of these tools, and we surface insights into their usage across all of IBM. And that team sits under the CIO directly, which is Fletcher Previn. And so my squad is the Insight Squad, which is part of Toolbox. We're basically the data analytics team within Toolbox. We use machine learning, data science, we create analytical pipelines to derive insights into tool usage across the company, as well as predict adoption trends. We perform analysis on all of the 14 tools that Toolbox covers, and we have a total population of users of about 500,000 people. So in 2019, we wanted to analyze the usage of GitHub across IBM and see how it had impacted the way that IBMers worked. So it's important to understand, before we get into all of that, kind of how GitHub came to IBM, because obviously it wasn't always there. So IBM adopted GitHub in 2015, and the idea was that it would improve developers' productivity and engagement, that it would encourage collaboration, code sharing, code reuse, all of that good kind of social coding stuff. And we also thought that it would probably improve talent attraction and retention. So currently, or the last time I checked, sometime last week, we have 70,000 active users right now within IBM of GitHub. And an active user is just anybody who's touched GitHub in the last month. So we have a lot of licensed users, but 70,000 active users. So in 2019, it's been 4 years since GitHub came to IBM, and we hadn't done any real in-depth level of analysis into how GitHub was being used, aside from just those kind of general usage numbers that I mentioned. So we knew how many people were active within GitHub, and we could see how that trended over time, but we hadn't done any in-depth analysis of what was going on with how people were actually using the tool. So we came up with a couple of questions. We were just trying to brainstorm, how do we see what's going on? And we wanted to know, how have practices around coding, specifically with regards to collaboration, code sharing, and reuse, changed over time? How are these behaviors around coding distributed across IBM from kind of a business perspective? And as IBMers have self-organized in GitHub Enterprise, is there a need for garbage collection? So the first question was important because we wanted to see if GitHub had fulfilled its use case, if it had actually kind of done the things that we thought it would do. The second one was important because we wanted to see how, from a business perspective, certain areas of the company were performing in those above behaviors. And the last one was important mostly because if you have things that are unnecessary in a large enterprise organization like IBM, you're probably costing money. You could probably save money by getting rid of whatever is redundant. And you might have people looking for, orgs that don't exist, for repos that aren't relevant anymore. So there's a motivation to keep your organization pretty clean. So our initial thought with how to undergo this type of analysis was to look at the GitHub API. We figured out pretty quickly that that would not work for our scale. It was just way too much, both on GitHub's end to handle and ours. So we decided to look at the database. So I want to go into kind of how we set up the technical part of that report, and then I'll get into what we actually found when we did it. But immediately when you sit down to a new project like this, you come up with the constraints. So the first one was we had to replicate the database. Our SRE squad was the one who was managing our IBM's instance of the GitHub Enterprise database. And we absolutely could not touch that instance because it was our production instance. And for a report like this in the early stages, negotiating that and dealing with that level of risk was just not something that anybody wanted to undertake. So instead, we decided, all right, we're going to have to replicate the database instance and host it ourselves. So that was the first constraint. The second was sanitation. We couldn't surface any private repo content, basically anything to do with repos that were marked private, or sensitive user information from the GitHub Enterprise database, and we couldn't increase our authority over the GitHub data. And what that means was basically we didn't want any of the additional responsibility that our SRE squad was dealing with, because they had the authority over the data to look at those sorts of things and kind of do that in-depth analysis. We wanted to remain pretty normal users of GitHub, so by necessity, we had to censor certain information that we weren't privy to. And the third was creating a pipeline. And this was partially just because of how the Insight Squad usually works. We prefer to make things in pipelines because we want things to be repeatable. You don't want anybody ever looking at stale data. And we want things to be able to be spun up fairly quickly and reliably, and to not have to do the kind of annoying translation works that come when you build your POC in Jupyter, and then you have to translate it to something else just to get it to work again. So those were our constraints, and I'm going to go into kind of how we addressed each of them. And the first one we started with was how we replicate the database and host it and kind of deal with that. So it's helpful to understand how we managed our other data sources, because we basically just slotted the database into our existing setup. So the Data Insight Squad uses a data lake with Hive and Presto to manage multiple data stores. We manage these instances with Helm charts, and we host them on our own Kubernetes cluster hosted on IBM Cloud. So the GitHub Enterprise database instance, we decided would just be hosted on our Kubernetes cluster and connected to the existing infrastructure. And that's a little wordy, so here's just the quick diagram that kind of makes it really clear. Presto sits above everything else over Hive, connects directly to the MySQL GitHub Enterprise database, your views, and Hive is where we put the tool stuff like Slack, Safari, all those 14 tools, as well as the business information, which is what Blue Pages is. So we're able to pretty easily connect the GitHub Enterprise database to Presto and use the existing Presto structure to connect that information to anything else we want. And then we moved on to sanitization. So privacy was a big concern for us. We talked with the SRE squad and other domain experts about where private repo content and SPI might be stored in the database schema. I also looked through all of the, I think it was 300, nearly 400 table schemas just to see what seemed like it could potentially be sensitive information. We had a sit-down meeting where we figured out what exactly we wanted to censor. And once we identified what we weren't allowed to look at, we censored columns with zeros rather than removing them. You never want to actually delete any information, right? So we decided the best thing was just to zero out any columns that we didn't want to surface. And we managed all of that with Squitch, which if you're not familiar, it's just a tool, a database management tool that allows you to have a deployment job, which in our case was the censor job, the verification associated with that deployment, and a revert job. So we had an individual job for every act of censorship that we wanted to perform on the database. We could verify each of those to make sure that the information was actually zeroed out, and if it wasn't, we could revert it, try to figure out what went wrong. And so all of that kind of went into building the pipeline. And there's a diagram that goes into this a little bit better on the next slide, but I'm just going to talk a little bit about a big part of setting up our pipeline was negotiating with the SRE squad about how often we would receive the data. So we settled on a monthly basis. They received daily backups of the GitHub Enterprise database instance, and we asked them to basically, on a monthly basis, combine all of that and give us that huge file. And we picked that because it was about as fine a granularity that you really want to get into with these kind of long longitudinal studies. Looking at how something did on a week-by-week basis over the course of 4 years isn't really helpful. And also because, as I'm going to explain, the pipeline takes about 24 hours to restore all of that data because there's so much of it. So a job that takes about 24 hours to perform, we could handle that about once a month. So it made the most sense for our initial use case. And once we have that data, we update the Kubernetes YAML file to point to the latest database backup in our object storage. We run Squitch against the new database instance to ensure that it's sanitized, and then it's basically ready. So this is just kind of a step-by-step breakdown. We get the monthly backup into our cloud object storage. We manually delete the old database. We update the YAML for the database configuration to point to the new database. It spins up the deployment. That's the part that takes about 24 hours because it's dealing with all of this data. And then once that's done, we drop the old switch database, create a new switch pod, and if all of the sanitization jobs complete successfully, then we declare it ready to be queried. And querying the database, like I said earlier, since it's connected to our existing data lake, we're able to just query it directly through Presto. Access to the Presto instance is limited to the Insight Squad members, so only people directly on my team are able to actually directly touch this instance of the database. And we use Chart.io as a data visualization tool. And Chart.io is basically just a dashboarding tool. It allows you to connect to data stores like Presto. So we created a secure SSH tunnel that we also hosted on our cluster. You connect Chart.io to that, and you're able to just create a new dashboard and directly query the database instance. So we had all of the technical stuff in place. We were able to query the database, and we had a vague idea of what we were trying to figure out, what we wanted to analyze. But now I want to go through how we broke down each of those three questions I mentioned earlier and what we actually materially looked at in the database to come to those conclusions. So the first one that we looked at was how do we analyze these coding behaviors? Because again, we wanted to see if GitHub had fulfilled its original use case, had it increased the social behaviors that we were expecting it to. So we talked to our SRE squad and some other people with domain knowledge to figure out what would help track the behaviors in which we were interested in. We also wanted to look at the number of private versus public repos because we considered that to be a fairly good measurement of if people were engaging in social coding and kind of breaking down silos. So we were aware pretty early on because we were talking to users as well as the SRE squad and the higher-ups that there would be a gradient in how people were engaging with GitHub. And our own model of engagement looked something like this kind of four-tier I don't want to say shallow, because that's kind of passing judgment, but just different levels of engagement. The first being people who are just opening or commenting on issues. And we knew that those users existed because we talked to people in sales and other kind of non-technical roles who just really liked using GitHub for issue tracking. So that's one level of engagement. And the second is people who push code. The third are people who open PRs. And the fourth are people who are reviewing PRs. So we kind of imagined this tiered approach to a shallow involvement with just using kind of the tools for issue tracking, engaging in coding behaviors, engaging in coding behaviors subject to peer review, and then actually providing the valuable service of peer review. And the database has tables that correlate to all of those pretty directly. So there's a table dealing with when people are reviewing PRs, opening PRs, pushing code. So it's fairly easy to just break that down by when those behaviors occurred, connect them to unique identifiers, and get the aggregate count, which is how we approached it. And the second question was, how do we connect this to business info? So we decided to break down the results of some of our queries across business units. And that's an internal IBM term. There's about 10 of them in the company. They range in size from 10,000 employees to around 100,000. And we picked business units because, one, they were of interest to our stakeholders. VPs are usually pretty interested in how their huge group is doing. That's kind of the level that they tend to look at things. But also because it was high enough in the employee chain that reverse engineering any sort of personal information would be completely impossible. We wanted to eliminate the scenario where you're able to search by manager and you stumble across a 3-person team and suddenly you're able to figure out how your neighbor's performing or your boss is able to criticize why haven't you contributed to our commit numbers recently. We wanted to avoid that entirely, and there's really no way that somebody's going to pick you out of a crowd of 10,000 to 100,000. So that was the safe bet, and we went with that. And the third question was, what does organizational hygiene look like? So first we had to identify what structures were available to people in GitHub. How can people self-organize? And there's basically only three. There's repositories, teams, and organizations. And those are the structures that you can create on your own and manage. And this one actually was kind of the most interesting thing to debate because it raised a lot of really interesting questions about what is something that's unnecessary, especially in this kind of enterprise space. Is it a repo that hasn't been touched in 6 months? Is it a year? Is it an org that's kind of just a duplicate of a team? What is unnecessary? And we basically decided to just go with the strictest possible definition. So after some discussion, we decided that the only way something was unnecessary was if it had been abandoned. And things were abandoned if they were comprised only of people who no longer worked at IBM. So if you made a team and then everybody left the company, but you forgot to delete the team on your way out, or an org, or a repo, that was an abandoned structure and it was something that was unnecessary. And it's a pretty strict definition. I think there's room to explore this a little more in further iterations, but that was what we went with for the initial report. So before I get into kind of the charts that we actually produced about it, I want to go over the results broadly, because I think that that's more helpful than just kind of pointing at some charts and talking about them. So the first question that we looked at was, how have practices around coding changed over time? And we found a steady increase in the numbers of users pushing code, engaging in collaborative behavior over the years. We also saw a similar number of private versus public repos, and I'll get into that a little bit later because it's one of our kind of follow-up actions. And how are behaviors around coding distributed across IBM? We saw a really wide variation. We were able to connect them in kind of expected ways. So sales teams had fairly low percentages of people reviewing code, which is what you would usually expect. And then the last one was, as IBMers have self-organized, is there a need for garbage collection? And we did find abandoned structures, so there was a need for garbage collection. But we didn't see as many as we had feared, especially with a really large company. We were a little bit afraid that once we got in there, we would see that there were a lot of abandoned teams or orgs or repos, and the numbers were actually pretty low, so we were happy with that. And I've broken up some of the charts that I want to look at just by the questions. So again, how have practices around coding changed over time? And so you can see that the pusher count is climbing steadily and significantly to around 42,000. And at the same time, you see the percentage of users who are pushing code dropping. So the percentage is the overall percentage of users of GitHub Enterprise who have ever pushed code, or the count of users in the GitHub Enterprise system who have ever pushed code. And for us, when we saw this, we immediately connected it to that first tier of the user engagement that we identified earlier. So if you look at the beginning, in 2015-02, I think we only had 3 people using GitHub. And of course, those 3 people are early adopters. They're the first people to get on the system. They're going to be developers who are really interested in using GitHub for a development use case. But as time goes on, we see more people adopt GitHub for issue tracking only. And that's why we see the increase in the count and the simultaneous decrease in the overall percentage. And this is a graph of the count of public and private repositories. So a little bit of explanation. Basically, at any month and year on this graph, it's looking at of the repos created in that month and year. What is the count of public? What is the count of private? Public being green, private being red. So at the end, we have about 261,000 public, 200,000 private. So the number was closer together than we would have liked. And this has actually been the subject of my team's kind of focus before. A couple of years ago, a colleague, Jeff Jagoda, gave a talk at GitHub Universe about his efforts to increase the number of public repos versus private repos in IBM's instance. And so this is something that we're kind of going to continue to address in the follow-up. And this, again, is just similar to the pushing. This is showing the overall count versus the percentage of people who are reviewing code and people who are creating pull requests. And this further validated our kind of four-tier model because we saw that there were around 26,000 people who were opening pull requests, so less than people who were pushing code, and even less people who were actually reviewing code, only around 19,000. And that's, that's kind of to be expected. There are always less people reviewing code than you want. There's always people more willing to open PRs than review. But it was interesting to see the same overall trend of the count continuing to grow while the percentage of overall users shrinks slightly. And the second question was, how do we look at these? When we look at these distributed across business units, how do they look? So at the request of my boss, I have censored the names, but you can see that there's a pretty wide variation in how these behaviors are distributed. Same for, again, the pull requests versus performing review. Even among like similar business units, you'll see that maybe there's, for some reason, the bottom one, second from the right, has a lot of people opening pull requests, but an extremely low amount of people reviewing pull requests. So that one, this behavior was pretty interesting to us. And as IBMers have self-organized, is there a need for garbage collection? So the first thing we made was a heat map that was just shouldn't have touched that. We made a heat map that was showing the number and the count of abandoned structures, and each of those rows, again, I guess each of those columns corresponds to a business unit whose name I've chopped off of the bottom. But you can see there were kind of clusters of organizations that were abandoned versus repositories versus teams. And actually we found that the most likely thing to be abandoned was an organization. Repositories were pretty rarely abandoned, and teams were kind of middling, somewhat often abandoned, but not as much as organizations. And when we looked at the actual counts, we were pretty happy because each of these lines represents a business unit, and at the maximum, we saw 56 abandoned teams, which in a group of up to 100,000 employees is pretty decent. And same for repos. We only saw at max 17 abandoned repos, so people were doing a pretty good job of cleaning up after the repos and shutting them down when they were no longer necessary. So the implications of these findings, like what do we do with this? What do we take away from it? And we saw it pretty clearly. We have a fairly high percentage of users at IBM who use GitHub Enterprise without pushing code or engaging in those collaborative coding practices that we were trying to measure in the first place. So who are these people? From talking to some users, we had a pretty fair idea that they were mostly salespeople or managers who were in touch with technical teams and wanted to stay on top of what people were doing, but weren't actually engaging in code. But we didn't do a really in-depth analysis of that user population for this report. Our initial focus was more how has the use case of GitHub been carried out. So we saw pretty clearly that we needed to do further analysis on this population and figure out what were they contributing to the GitHub ecosystem at IBM, how is their use affecting how other people were using it, just what are they doing in the community, basically. We saw that there was garbage to be collected, so we have to figure out how to go about doing that. It's tricky to contact somebody to clean up an org when everybody in that org no longer works for your company. So we need to figure out a solution for maybe preemptively recognizing that something is at risk of being deprecated, or taking authority over something where everybody is gone from the company. That's a question that we still have to address. And the number of public and private repos is near even. Is there anything we can do to encourage more public repos? Like I mentioned earlier, we had a colleague who attempted to do something like this kind of early on in GitHub at IBM, and his solution involved putting a hook on every repo and opening up an issue in the private ones, kind of politely asking, are you sure that this needs to be private? Could you please make it public? And that quickly became unfeasible due to the scale of what we were dealing with. So we haven't attempted anything similar to that since then, and this kind of seeing how close the numbers were kind of made us think that we need to address this moving forward, whether through communication or some other method. And so we came away with a couple next steps. Further automation of the pipeline using Airflow. We've recently used Airflow on our team to complete, well, to schedule a couple of things for some other repeatable processes that we had to do, and we found it helpful. We also want to reduce the latency, obviously. Like I said, it takes about 24 hours to spin up a fully functional instance of the database and start querying it. So we would love to get that time down slightly. We want to keep promoting the work within IBM as a resource for people to use to keep abreast of trends within GitHub. So I didn't show you, the whole report exists basically as this big Chart.io dashboard with a bunch of charts. And the full report is available to anybody who works at IBM because it's all information that they're able to look at, so they can see how their BU is doing, how trends increase or decrease over time. So we want to continue to promote that and encourage people to look at it and kind of get a feel for their place in the larger GitHub community. We also want to continue the conversation with stakeholders and domain experts about how to get the information from the GitHub database. The database is a really, really rich source of information. I didn't go into it too much, but they have tables that would allow us to figure out the mean closing time for an issue, like clustering patterns around comments. And that's something that we want to look at in the next version of this report is, okay, you open a pull request. What's the actual mean time for a pull request to get closed in IBM? Do we see how that changes over time? Does that tell us anything? There's a lot that we can still pull out from that data store. And we want to do similar in-depth studies on other tools that we manage. So the type of analysis that we can do on tools is limited by the data that we receive. And luckily for us, the GitHub database has a wealth of information. But this is really the only type of report like this that we've been able to do. We want to expand it to some of the other tools we cover, like Slack or PagerDuty, Safari books. We want to keep doing kind of this really in-depth user studies on all of the other tools that we handle. And that was it. That was all I had.